there's an important distinction between one-tailed and two-tailed tests. So most tests are two-tailed, okay? It means that you have your chances of going up or down. So you assume that the main number is equal to 0, okay? And that you can reject that null hypothesis by finding that the main number is larger than 0, which would be around here, or smaller than 0, around here. Some tests can be one-tailed though. So the main number is smaller than or equal to 0. So it's a situation in which you can only expect the number to increase. And then the tail is only on one side. Or on the other side, it could also decrease, for example. Okay, the main number is equal to 0 or greater than 0. This is how you write this null hypothesis. This, you write the main number is smaller than or equal to 0, because it's scanning all the possibilities up to this critical value, or from the critical value and up, all the way up. So you could ask me, like, what is the situation when you use a one-tailed test? Well, for example, when you have depression pills, you know, if you're taking SSRIs, which are the antidepressants. Usually, if you're testing SSRIs, you're only going to test if they're going to make your depression better, because they can't really make your depression worse. You know, it's just like a liquid you're taking. They're usually going to make it better. Like they have to make it better. That's the whole thing that they were designed for. So if you're a researcher and you're sure that the number can only go up, you can use a one-tailed hypothesis, but you have to have very good reasons as to why you use that. Okay. Because, you know, have to have a very good rationale as to why you think can't decrease, you know. Everything that you think about, most things that you think about can both increase or decrease, you know. Instagram could make people happier, you know. Instagram could decrease depression, for example. It's possible. Why not? You know, why would you say that it's only increasing depression? Maybe getting in touch with your friends makes you happier. Who knows? So that's why we used the two-tailed null hypothesis for Instagram. Now, one tail is larger than two tails. This is one thing I wanted to show you. Because this critical value here for one-tailed is way closer to the center than the two-tailed. Why? Because one of the sides is being transferred to the upper side, right? So before we had 2.5, 2.5. Now the 2.5 that we had there got sucked up onto the other side. That's why it's a little bit bigger. And that's why that's also going to affect your critical value. So your critical value now is 0.82. when it was before 1. Why? Because we move the bar, so we have to, the value is different, right? The z-score now changed too. So z-score for a H0, the zero score now changed too. So the zero score for a one-tailed null hypothesis is 1.65, and a z-score for a two-tailed null hypothesis 1.96 on each side, right? But now it's 1.65. This is just the thing that I'm showing you. Now, the p-value is interesting because it doesn't get sucked up onto the other side. That's the interesting thing. If you have a one-sided p-value, it's going to be occupied the same area as the two-sided p-values, except that, you know, you don't have this area here, right? You don't have this p-value here. So instead of getting sucked up, the p-value doesn't get sucked up. P-value just used to be here, right? Because this is a two-tailed, and it's no longer there, but we still have the same sock. So think of a p-value as a sock, right? Here you had two socks, and they have the same size, okay, on each side of the tail. And here you lost a sock, and it's still the same size sock. It's still the same size sock, but it's there. For that reason, we say quite intuitively that the p-value for a one-sided hypothesis is half the p-value for a two-sided hypothesis, right? Because here's 0.15, here's 0.30, because here you have two socks, right? 0.30, here you only have one sock. So keep in mind, okay, like this can be very confusing, so you can always refer to this class to remember. Here you have, you know, a p-value of 0.015 is 1.5% on only one side. A p-value of 0.03 is 3%, split into two sides, 1.5, 1.5. Okay?